As inventions go, the Haber-Bosch process might be the most important for human survival. It enabled mass production of nitrogen fertilizers, which help our farms produce more than ever before.
The object is to produce an early crop maturity and consequently more grain volume.
Food is more affordable, and billions of us have avoided starvation. It's been so instrumental to the existence of our species, it's estimated half the nitrogen in our bodies is made synthetically. This is how we harnessed thin air to feed billions. Around the beginning of the 19th century, population started to grow faster thanks to the Industrial Revolution. But it was hard to grow enough food. Harvests are unpredictable and could take months to renew for the next planting. It became clear to scientists that nitrogen was a key ingredient for growing crops. In nature, when plants die, the nitrogen they contain returns to the soil and new ones grow using it. But agriculture disrupts that cycle. So farmers started using manure and compost which contain nitrogen. But it was never enough. By the mid-19th century, the superpowers of the time went to extraordinary lengths to get better fertilizer. Hundreds of British, German and American ships travelled to islands off the coast of Peru to load up on bird droppings. Guano has high nitrogen content, so thousands of tons of the stuff were mined and shipped across the Atlantic. But it ran out. Luckily for the men mining it, something more plentiful and nitrogen-rich would come along. In 1909, German chemist Fritz Haber managed something that had eluded scientists for decades. He synthesized ammonia from nitrogen gas. Even though 78% of air is nitrogen, turning it into useful ammonia fertilizer is extremely difficult. Nitrogen doesn't exist as a single atom. It exists in a largely unreactive form, as two atoms coupled together with triple bonds, the strongest in nature. Simply put, it's incredibly hard to break down. It happens naturally, but it's rare, either by lightning pulsing through the air or bacteria slowly eating away at rotting vegetation in the earth. Haber initially tried to mimic a thunderstorm to produce nitric acid, but he only got small amounts, so he began to work with high temperature and high pressure. Germany's largest chemical company, BASF, had engineer Carl Bosch help Haber turn it from a lab experiment into a commercial process. The team had to invent much of their equipment to handle the extreme conditions and worked in a concrete chamber away from other workers due to frequent explosions. When completed, the Haber-Bosch machine stood nearly 8 meters tall and produced 90 kilos of ammonia per hour. But it wasn't used to create fertilizer. Not initially anyway. By 1914, the world was at war. Germany was struggling to manufacture explosives due to shortages of nitric acid. A proud patriot, Fritz Haber became involved in the war effort and began to produce poison gas. In 1915, chlorine and mustard gas at the Battle of Ypres would kill tens of thousands of troops. Haber reportedly watched the field of battle as the gas was released on Allied troops. Haber's wife, Clara Immerwahr, a prominent chemist in her own right, was sickened by his involvement and would commit suicide by shooting herself with Haber's army pistol. Despite effectively becoming the father of chemical warfare, Fritz Haber's achievements in synthesizing ammonia would lead to the award of a Nobel Prize. Together with advances in breeding, synthetic nitrogen fertilizers more than tripled average US wheat yields during the 20th century. The planet's human population exploded from 1.6 billion in 1900 to nearly 8 billion today as it became easier for people to secure food. As fertilizer use ramped up after the Second World War, population growth accelerated. It wasn't just human life the Haber-Bosch process supported. Billions more animals were farmed to satisfy human consumption. Of course, there is a price to pay. A huge strain is placed on the environment by the number of mouths to feed. A lot of the nitrogen in fertilizer fails to make it into the food chain and pollutes our water. So as our population continues to grow, and the more we rely on the Haber-Bosch process, the more nitrogen will leach into the environment. That is, unless we choose to reduce our meat-heavy diets. It also takes a lot of energy to make ammonia out of nitrogen. The process burns 3% of globally produced natural gas and releases another 3% of carbon emissions, so it isn't a guilt-free miracle. But with almost every meal that we eat, we benefit from the Haber-Bosch process, providing the world with easy and affordable access to nitrogen. If crop yields remained at 1900 levels, we would need 4 times more land to farm on. That's nearly half of all ice-free continents, rather than the 15% it is today.